Welcome, everyone, and thank you for coming today to this session. My name is Kenan Owens, and I'm a technical product manager on the System Center, Data Center management team focusing on virtualization. Today we're going to talk about virtualization, some clustering tips and tricks, mainly focused on Hyper-V and the Windows Server environment. What I've done is broken this down into just a list of a bunch of different tips and tricks that we've seen and people have talked about over the while that Hyper-V has been released. And we'll go through this session. We'll talk about both the Hyper-V clustering, some techniques for there. Then we'll talk about management and some other things as well. So failover clustering and Hyper-V. Why are customers using failover clustering with Hyper-V? Well, with any type of virtual machine, especially if you have a lot of virtual machines running on a system, you really want to have some protection just in case it's failover. Obviously, if the system is going to go down, you want to be able to move them before they go down, and if it does go down, you want to make sure that they get up as quickly as possible. So before I get started, who here is using Hyper-V for virtualization? A great many of you, great. Who here has it clustered? Using live migration? Great. How about VMware? Who's using VMware? Excellent. Who's got that clustered? Who's using vMotion? Fantastic. All right. So you all understand the needs for clustering, so we won't go much into that. What we'll do now is we'll start going into the list of the different tips and tricks that you'll go into. And I think this first one, and I think it's probably the most important one that a lot of people overlook, and that is that where you store these virtual machines, you want to have the best IOPS that you can possible. Spindles, spindles, spindles. Don't move a lot of virtual machines that each require X amount of spindles onto one shared LUN, and that LUN only has that same amount of spindles. You're definitely not going to get performance. In other words, that does not equal that. And it's important to understand this because what happens is that organizations will look and then maybe they want to virtualize a SQL server, or they have 4 or 5 SQL servers they want to virtualize. Each one of them has a shared data store up on the SAN. And a lot of people say, okay, well, we've optimized that for that physical environment. Then they'll take all those different physical environments and they'll put it all together on one big LUN of a SAN that's basically just a RAID 5 with a bunch of SATA disks or something like that. I mean, they don't get the performance that they're expecting, and therefore they say that virtualization is not working for them, when it's actually not the virtualization, it's the SAN backend. So if you have virtual machines with high I/O requirements, make sure that they are put on SAN storage that has the I/O capabilities. Now that SAN can be Fibre Channel or SCSI, doesn't matter, but it needs to be on some type of shared storage to be able to handle the IOPS that the virtual machine is going to need. And that's very important, and that's why I put that as number 1. Now we're going to kind of jump around to a few different areas, but the next one is, let's say you're a small organization and maybe you don't have shared storage. Well, you can still build clustering and availability, and to do that, you got a couple of options. One of them is use a third machine and put some type of SCSI target on top of there. You know, there are many different organizations that, many companies, IHVs, that create those types of software, like DataCore or Left Hand has one as well. The other option is to use something like a virtual storage appliance and create a virtual machine that stores the virtual data. That way you can still gain for all the other machines on there live migration and vMotion capabilities, but you have this shared storage now to enable that clustering. Now both of those would most likely be using iSCSI, but you know, in some of them you can set up Fibre Channel if it's a third machine, like with DataCore SAN Melody or something. Now if you can't afford or don't have that third machine or don't want to put the data inside of a virtual storage appliance, you can easily gain availability. It wouldn't be high availability, but higher availability by using tools like Data Protection Manager, where I have a VM that's stored on one box and I back it up to a box to the other box so that I can restore it on that box and bring it up if I need to. Jason Buffington has a bunch of good sessions this week on Data Protection Manager and all the advances that we've made with DPM 2010 that work well for virtualization. So if you don't have shared storage, you can still gain the availability either by using a iSCSI target, or data protection manager. The reason customers use virtualization is they get the clustering capabilities without having to actually have an application that's cluster aware. So you're clustering the host, and that allows you to get these cluster aware applications, or these non-cluster aware applications clustered. By host-based clustering, we provide the VM mobility for both planned and unplanned downtime, as well as we get the monitoring and availability for these virtual machines, meaning that I can see what's going on with the virtual machine and take corrective action if something happens to it. And we'll talk a little bit about that in a few minutes. So planned downtime, using techniques like live migration or quick migration on Hyper-V or vMotion on VMware, I can move virtual machines from one box to another with no downtime. Great for maintenance capabilities or to rebalance my workload. And this is the reason we use it for unplanned downtime. If I lose that host, I can bring the host back up. So the VMs are cold restarted on that new server. Just be careful about that. And we'll talk a little bit later about whether that server has to be located at your site or at a different site. OS health monitoring. This is where you can take an application that's not cluster aware, and I'll show you an example of that in a little bit, like VMM, our virtual machine manager product right now, and you can have it restarted on another system to gain that availability. If the system goes down, you can bring it back up. So cluster your non-cluster aware apps, get the availability by putting them inside a virtual machine. If I do have a cluster aware app, can I use clustering inside of VMs? And the answer is yes, you can. And you should for applications where you can take advantage of it. So I can take an application like a SQL Server and store it inside a VM, and I can use an iSCSI target to access the shared storage that SQL Server is storing the data, and I can cluster it either with another virtual machine, or actually, we'll talk in a few minutes, another physical machine. With that, though, the shared storage piece of it has to be through an iSCSI target for Hyper-V environments, because we don't pass through a virtual fiber channel adapter. So when I'm guest clustering, I get the advantages of taking that service and moving it to another application without the application going down, even if either that virtual guest OS goes down or that physical system goes down. So what does app mobility give me? Well, the application is health checked by the failover clustering service inside of the VM, and I take the storage and I present it directly to that VM via an iSCSI target. Because it's presented via IP, if I move the VMs around with live migration or vMotion, they're still up and running. Everything's still running just fine within that system. So quick recap on clustering. For host-based clustering, you want to use that for apps that don't have cluster capabilities, or if you need zero downtime moves while the app is running, which for most people is most applications. Guest clustering is great for when I support clustering inside the VM on that application. I can move it around without having downtime there. All right, now we'll go into some of the probably more fun stuff. So one thing to remember is you need to use the appropriate storage for the clustered environment that you have. So the physical host, where that VHD is stored, if you're going to have it in a clustered environment, has to either be on a fiber channel, serial attached SCSI, or iSCSI environment for that virtual machine's VHD. Now inside the guest, if the guest is clustering with some other VM or a physical host, then that guest, the data for that guest needs to be accessed, can only be accessed via iSCSI. So the VHD for the OS image for that guest can be on a fiber channel, serial attached, or iSCSI, but the data that the guest is sharing with the other machines for the clustered environment needs to be on iSCSI. All right, so clustering both your guests and your clustering both your hosts as well as the guests kind of gives you the best of both worlds. It allows you as an environment it allows you as an IT organization to provide an infrastructure that will be available for the application, but then you get, when you only cluster just the hosts, you get that OS level of protection. So if the OS goes down, it'll fail over because the application will go down. But you don't get the application level of failure. And that's where you do the guest clustering. So you put them together, and that helps for moving that application over. But there are some things that may how do I say this, that may not appropriately work depending on where you do actions when you have both the host clustered and the guest clustered. So for example, if I have the host system running and a VM's running inside of that host system, and from within the host system I do a start shutdown, that VM isn't going to be restarted on another system. Or that VM is going to appear like it's down and it's going to be restarted on another system. But when I do it from outside of the virtual environment and I do a shutdown from, say, VMM, then the cluster won't restart it on another system. So there's some things that get kind of out of whack when you have something clustered inside a VM and you do different application activities within that guest operating system itself. All that really means is that just be prepared for when you want to stop the VM, the best way to do it is from outside the virtual machine and do a shutdown from outside the VM. You'll be able to do that, and then the cluster will be aware that it shut down properly. And if it's clustered inside the VM, then the app will fail over before it shuts down so that you'll still be up and running. So if you have a networked environment, and this will probably really happen more on, say, a host or multi-site cluster, but even on an internal cluster, you may have times when the heartbeat may not go across the system in time, and the clustering environment may not recognize the heartbeat. You have a lot of network traffic on the same wire, or you have some slowness when you're trying to do things like a live migration. So there are a couple of settings that you can change inside of your clustered environment to increase both the timeout of the heartbeat as well as the number of heartbeats that the cluster might miss before it will initiate that failover and say, hey, this machine's down, let me fail it over to another system. And these are the two settings, and I'll show you how to set these later on. But they are same subnet threshold and same subnet delay. So same subnet delay would be how often it does the heartbeat, defaults to 1,000. So that's 1 second, 1,000 milliseconds. If you want to increase that due to latency in your network, you can bump it up, 2,000 for 2 seconds or whatever value you want there. The same subnet threshold is how many misses of the heartbeat does it take before it realizes that, hey, the system's down. And by default, that's 5. So what that means is within 5 seconds, failover clustering will know that this host is down, and it'll bring it up and it'll initiate the failover and bring it up on another system. I'll show you where to set these and how to set these through PowerShell in a little bit. But here's a document on what it means and what to do, how to change some of these things. There's another 2 settings for multi-site clusters, which we'll talk about later on in this session. So many people are running applications where they don't want the 2 servers to be on the same node. So let's say I'm running a web-based application. I have multiple web servers. I don't want those 2 web servers to be on the same node, because if I lose that node, then I lose my web environment. And so clustering didn't help me. So I can keep them off the same node by setting anti-affinity policies. So I can, within the host cluster, set up an anti-affinity class, and I can put the VMs that I want to not be in the same host inside of this to tell them, hey, we want these 2 things to be split up. And here's the KB article where you can go through and go through the steps to set that piece up for you. This is also good if I have a cluster. Let's say I have a virtual machine, 2 virtual machines, they're clustered SQL. They could reside on the same host because they're using iSCSI for that shared disk, but I want to keep them apart. So it's not just for web environments. Next, I may have a set of systems that I want to restart when that cluster comes back up. So if I lose a host or I bring down the cluster, when that system comes back up, I want to bring up these virtual machines. And that's enable persistent mode. And I can do that within the failover cluster manager and just click on the box, enable persistent mode. Not only will it bring it up, it'll try and bring it up on the same node that it was brought down on before. All right, so who here is doing any type of physical to virtual clustering? Just a couple of you. Are you using iSCSI for the transport for the shared storage? Yeah, so when you cluster physical and virtual environments, it's supported and it works. Just what you want to do is you want to make sure it passes the failover cluster, what do you call it, the validation test. And what this does is it allows you, say, if you wanted to run a physical environment for a SQL server, but you wanted a backup of it, you could create that backup inside a VM. Or I could have like 10 or 15 servers with 10 or 15 VMs that are the backups for each of these servers in like an active passive type environment. That way I don't have to have two instances of server environments for every single application cluster. Another reason people use a physical to virtual clustering is for a migration path. I had one customer that was moving to Exchange from Exchange 2003 up to Exchange 2007, and they took the Exchange 2003 server that was running on a physical box, they clustered it with a VM so that they could move the system off of the physical box onto the virtual box. Then they were able to take that physical box, upgrade it to 2007 while the 2003 VM was still running and servicing their customers, and then they were able to move the VMs back over to that original box, and then get rid of the cluster. So they used it as kind of a migration path to move from one environment to another. Yeah, there was still some downtime when they were doing some of the movement, but what it did was it allowed them to do most of that movement without downtime to their customers. All right, who here is using CSV with their Hyper-V environment? So the CSV was one of the nice additions to Windows Server 2008 R2. It was designed specifically for virtualization in Hyper-V. People ask me, is it a true clustered file system? And it wouldn't necessarily call it a true clustered file system, but in the same respect, I wouldn't call VMFS a true clustered file system either. But they're very close. In other words, they allow multiple servers to access different VMs on the same box at the same time without it affecting each other. So CSV is nice because it was designed and built on top of NTFS, and that gives you all the benefits of NTFS, like many, many, many different numbers of files, as well as it's designed to fit in the clustered environment within failover cluster server, so you can have all these different servers within your cluster accessing that same file share. Now, is there a maximum to the number of VMs that you can place on CSV? And the scientific answer is no. There's not really a maximum as to the number of files that you can have. I mean, you'll have more. You won't be able to fill up as many VMs as you could possibly fit on this one CSV volume. But is there a practical limitation as far as the number of machines that you access and put on the same CSV? And the answer there is there's no like guidance limitation, like you can only put 32 VMs, you can only put 16. There's none of that type of limitation. The real limitation is if I got a lot of servers accessing the same number of the same LUN, and that LUN has only a specific number of IOPS that it can handle, then if I put more and more and more VMs on there and they all need disk access, I'm obviously going to have, run into some bottleneck somewhere. But it's going to be an infrastructure type bottleneck, not necessarily a bottleneck with regards to CSV. In other words, C rule number 1, spindles, spindles, spindles. Make sure that that data is up there and ready to go for the VMs. If your storage infrastructure is set up fine, you can run as many VMs as you want. Now, what I've seen with a lot of organizations is that they create those CSVs at about 500 gigabits per CSV. And the reason for that is just the number of VMs that they want to store per CSV. It kind of fits right for them. And whenever they allocate a chunk of storage to a virtualized environment, they can chunk it in 500 gigabyte increments. That's just things I've seen in customers out there, but everybody's mileage is going to vary depending on their SAN infrastructure, the type of SAN environment, and the number of virtual machines they want to run. One of the nice things about CSV is that it's not increased is the right word, it's added an extra layer of availability that actually VMFS doesn't have. So CSV allows you to have multiple machines access different VMs on the same LUN at the same time. And how we do that is for the VMs to be accessed, or for the Hyper-V servers accessing the VM to do just normal disk operations, it handles it directly through direct access to that file, that VHD file. But if I need to do metadata operations, what happens there is all the metadata operations go through a coordinator node. That way, one coordinator node manages things like file grow, creating new files, those types of things. But when I'm accessing the data on that file, the virtual machine data is, virtual machine writes are just written directly to that file. I don't have to lock the LUN to do that. It's very similar to the VMFS operation. The thing is, though, is that if in VMFS, if I take each of those ESX servers and they want to do things like an access to a LUN, and they want to expand a file or create a new VM, each of those ESX servers would then try and lock the LUN. And if the lock failed, it would pull off and then try again and again and again until it was finally able to lock that LUN. Because all of the metadata traffic is coordinated through one server, then we don't have to worry about any type of collision when we're trying to lock the LUN to do things like add files and those types of things. But because we have this coordinator node, we actually gain a level of availability. If I lose my direct path, let's say this VM on the right loses access to the VHD, the CSV file, well, we can actually pass the data that we were going to write to that VHD through the coordinator node. So what this means is that I could lose my whole path to the LUN and still have access to write data by routing it through the coordinator node. Now, I wouldn't have as fast of access as if it was directly accessing the LUN, but I'm able to keep that machine up, and then I notice that, hey, I'm having trouble accessing the storage, I can then live migrate the VM off to the other box, bring this guy down, fix it, bring him back up, move the VM back without any downtime to the VM, but I've lost a whole path connection to the LUN itself. So we gain this extra layer of availability. Now you may say, well, you have this coordinator node. What if it goes down? You know, what happens then? Well, the coordinator node, if it goes down, then the coordinator node will just move to another one of these systems within the cluster, and that one will be the coordinator node until it has a problem. So you'll still have that metadata protection, because if the coordinator node goes down, another system will take that over and continue to be up and running. So CSV is a nice addition to Hyper-V because it breaks this one VM per LUN bond that Hyper-V R1 had, and a lot of our customers said, you know, I can't handle 550 different LUNs for 550 VMs. I definitely want to have a less number, and CSV gives you that. So if you're using clustering, a tip is use CSV. Now, some of the nice things about CSV is, since it is NTFS, I can take the existing LUN that may have been dedicated and not a CSV, convert it into a CSV environment, and then if I wanted to, I could expand it and put more VMs on that system. There's a question?
Just wondering, if you want to use dynamic disks, are they going to have a bit more performance hit in this sort of metadata approach?
So the question is, if I have dynamic disks that dynamically expand as I add data to them, am I going to have more metadata traffic and slowness by using a coordinator node? And the question is, and the answer is, if I'm using dynamic disks, I'm going to have, for disk operations where I have to expand the disk, those types of things, it does take a metadata change because I got to open the file, expand it, and close it. And so, yeah, I'm going to have more overhead than using non-dynamically expanding disks. But compared to, say, using VMware with their expanding disks, it's the same type of performance. I'm not going to doing that operation compared to like a VMware system is going to have the same performance hits. It's not going to be, it's going to be worse than if it was already pre-allocated, but it's not going to be any worse than our competitors. In fact, it's actually, we do less of those metadata operations, so you may even have less of them in VMFS. All right, another question is, what if I'm running my SQL environments, my Exchange environments, my file server, SharePoint, those types of environments? Are they supported inside of clusters? And the answer is yeah, they are. So we have guidance, specific guidance for each of these application environments. So if you want to run SQL, the host and guests are supported in the clustering environment for SQL 2005 and 2008. And here's the KB article that explains the support policy for that. Same thing with Exchange, if I want to run Exchange. So each of our applications that we have now, any of these applications that Microsoft supports, we have to make sure that that is supported within Hyper-V environments as well as outside of Hyper-V. And when it's supported inside Hyper-V, that means it's supported on Hyper-V in a clustered environment as well. So these applications are supported. Now, each of these applications may have specific caveats for like pieces of the application that may not be supported, or an entire application that may not be supported. But if they don't want to have support within Microsoft, they have to get executive level sign-off to say we're not going to support it. And the things like applications that aren't officially supported within Microsoft would be like our key management server, where we don't want someone to create a key management server and then just duplicate it many, many, many times and give it to all their friends or something like that. So those are applications that aren't officially supported inside of virtualization. But things like Exchange are, file servers, SharePoint, all those things are supported inside of Hyper-V. They're supported on clusters. So if you're thinking, I don't want to run these in a cluster, you should, and you'll get the benefits of getting that clustered environment. All right, so when you're managing your clusters, there are a few ways to do that. You can use Failover Cluster Manager, the GUI interface, and that gives you some capabilities for managing the cluster quick and easy. Nice things you can do there, initiate things like live migrations. There's cluster.exe, which was probably the way people would want to do it, but now you shouldn't do it. We're deprecating that capability, and instead preferred would be PowerShell, and use the PowerShell method to do clustering capabilities. So with that, let me log back in here. And what I'd like to do now is do a quick demo of some of the PowerShell capabilities. So within PowerShell, to get information as far as what types of things you can set and stuff in the cluster, get help cluster will give you all those applets or commandlets. Get cluster will give you the cluster information, which the two things that I use it for are the same subnet stuff and the cross subnet stuff, and we'll talk about that in a little bit. But when you want to do things like change values of the things you get from get cluster, you can't just do set cluster. What you have to do is you have to use more of the .NET format, and I'll show you what that is as well. This is a nice little TechNet article which kind of goes through the example of how to run that command right up there. So let's pop over to the demo here. Flip this down. All right, so as an administrator, when you want to, I'm on the failover cluster machine. So I have right here a 3-node cluster, conserve 1, 2, and 3. And these are Hyper-V hosts that are sitting down here running on a laptop. I have another server down here which is running a data core SAN Melody iSCSI SAN environment, and these 3 Hyper-V hosts are networked to there, and they're running the virtual machines off of this SAN Melody environment. It has within it one cluster shared volume, which is set up for about 500 gigabytes of space, and it also has another disk, which I have set up there, which is running a file server and some other things. So that's the environment. Now, what I recommend when you're doing a clustered, when you're doing a PowerShell with the cluster environment, right-click on, or open up the PowerShell, but do the Import System Modules option. So instead of doing like Run as Administrator, do the Import System Modules, and what that'll do is it'll load all the things to allow you to run, use the clustering commands. So I have this thing up here. So the first thing I might want to do is run, I should do this the other way. All right, get help cluster. And what get help cluster will allow me to do is it'll tell me all the different commandlets that I can use for the cluster, like start cluster, stop, and those types of things, as well as get the cluster information. So the next thing I may want to do is do a get cluster, and then I'm just piping it to FL format list. And if I just type that, what will happen is it'll give me the cluster name, but it won't give me all the information for the cluster. So what I want to do is I want to say, give me all properties of that. And so by hitting star there, it gives me the whole property of this clustered environment. So the cluster name, con HVCS001, but the two values that I was talking about earlier are right here, the same subnet delay and same subnet threshold. So those values right there. And then the other two are right up here. They're called cross subnet delay and cross subnet threshold. And we'll talk about both of these because when you're doing multi-site cluster, these are things that you might want to be interested in playing with or setting to make sure they're tailored to your networked environment. So let's say I want to change one of the values here. And I'm going to change the same subnet threshold value. So let's go down here. So what I would do is let's just bring it up. So what you would do is you would just run get cluster, but you would do it in a by setting the threshold here. So let me pull this down. Let me do this. Okay, so can you guys see that up there? Let me scroll it up here. So really what it is get cluster, and then what value of the get cluster object do you want to set, and what's the value you want to set it to. It defaults to 5, so 5 tries before it determines it's failed. Well, you may want to bump that up a little higher if your live migrations either take too long or there's some network weirdness going in the environment. So you can do get cluster, same subnet threshold. In this value, I'm going to equal 6. This can go up to, I think it's 10. So you would want to make sure that if you tried to do 12, it's not going to work for you. So same subnet threshold equals 6. Now if I do just and I look here, I can see that same subnet threshold value has changed to 6. So that way I can change these values depending on the settings I want to make. If I also wanted to change that delay parameter, same subnet delay, I can bump that up to say, let's say I want to bump it up to 10 seconds per heartbeat. Well, it's not going to let me because 10,000 milliseconds is too large for the environment. So it looks at it and says that's too high from what value you want to set, so it won't let you do it. So I can, if I wanted to, change it, though, however, to 2 seconds per threshold. And it'll allow me to do that. And then when I format the list here, we can see that same subnet delay is set to 2,000 milliseconds. So that gives me the ability to change some of these values for handling things like network latency and those types of things. So I'm going to change this back to 1,000, which is the default. And that's where you can set. Now, if I wanted to set a piece of the cluster, like if I wanted to set something about the networking, then I would do something to the effect of get cluster.network1, and I would change whatever value I wanted to set inside of there. And that's where in the slides, that link, it kind of shows you how to build it out if you want to set out both either at the main part of the cluster or inside of it, like the network environment or something. Okay, so let's go back here for now. The next thing you want to look at is making sure that your management of your cluster is highly available. Who here uses VMM for Hyper-V cluster management? Anybody? Or for VM management? VMM will allow you to manage your virtualized environment, but VMM is a non-clusterware application. VMM has multiple parts. Two of the main parts are the VMM server, the service running inside of a server, and the SQL database that it's connected to. So that SQL database, recommend running on a SQL server and clustering that environment so that if the SQL server goes down, you'll still have the clustered backend available. But then also VMM, ways that you can manage that and make it highly available. Even though it's a non-clusterware application, you can do things like cluster a host, put it on a host that's clustered, create a new service, running it. It's kind of like clustering the calc application. If it fails, it'll go over here and it'll restart, and it won't have whatever it had over here, but it'll restart, connect to the database, and resync itself. But I wouldn't put it on a physical machine that way because you're really just wasting space because it's not really going to take up the whole resources of a physical machine. So instead, a better way to do it is to put it on a highly available VM. So put it on a VM that's in a cluster. If that server goes down, it'll bring up the VM on another node within that cluster. And that's what I have in my environment. The other thing is the key resources like the VMM's library server and those environments, you would also want to put in a cluster. So with my VMM environment, which we'll switch back over here, did I do it? Yeah. Okay, so my VMM environment, I have a library server, and this library server has two pieces, but one of them is a file server, and that file server was that clustered share file server resource that I showed you earlier on, as well as it's connected to a SQL server. And that SQL server, though not clustered, is on a clustered VM, a VM that's highly available. And it's running on server 1 right here. I have my VMM server, which is also a cluster live migratable machine, running on conserv 002. And also within this environment, I have Tempo 1 and SM1. So I have 3 VMs on this one box, conserv 02. I'm actually running on my operations manager box, have VMM client installed, connecting to the VMM server. And what I'm going to do is I'm going to come down here, and I'm just going to pull the cable. Before I do, what you can see is that I'm pinging that VM server, so it's there and available. And now what I'm going to do is I'm going to pull, hopefully, the right number server here. Let's see, number 2. Does that work? Yep. Okay, so that server went down. Obviously, VMM hasn't recognized that it's gone down because it's not there anymore, but if I tried to do anything within VMM, it wouldn't let me. What I'm going to do is come back here to Failover Cluster Manager, and we're going to look under the Services and Applications, and you're going to notice that if we look at the nodes, we see that conserv 02, it already recognizes it's down. In fact, I wasn't here fast enough. VMM has already been restarted on conserv 03. So it's powering up already. So HA, recognized that, hey, this server went down, and it started the VM up on another box already. And if we come back over, whoops. Yeah, if we come back over here, Virtual Machine Manager isn't working because my client can't access the physical server, which is understandable. So let's get off of that. And we see that the VM itself is down. So let's wait a few seconds, and then that'll come back up. And then when it comes back up, then I'll be able to connect back into it. So I'll do that a little bit later in the presentation. Does that make sense? By putting it on a clustered environment, you see now it's coming back up, but we'll access that environment in a little bit. Oops, okay. So let's just leave that right there. Here, let me start the VMM application here. And then after this application starts, I'll go back and we'll connect into this in a little bit. All right. Okay, so connected into the server, sees that all the servers are back up now. And what it's going to do now is it's going to kind of figure out where all the machines are, because all those machines are gone. They've all been moved off of this machine and onto these other 2 boxes. So it's going to take a little while for VMM to figure itself out. But that's kind of how to make it more highly available. Yeah, it's going to go down, but you're going to be able to restart it and be able to reconnect into it. All right, so we talked about highly available VMs. Well, I have a clustered environment, and I have multiple servers in that clustered environment. What happens if I lose some of those servers, or I lose connection between some of those servers and other sets of servers? Maybe I have 8 servers in an environment, they're connected to 2 different switches, and one of the switches goes down, or the link between the 2 switches goes down or something. How do I make sure that I don't run into a split brain environment where one side thinks, oh, I have access to all these servers, so I need to stay up, and the other side thinks, oh, I have access to all these servers, I need to stay up? Well, there are ways to do that, and that's done through quorums. And quorums basically decide that whichever of these environments has more than 50%, whichever of these sets of hosts is more than 50%, they're the ones that's going to own the quorum, and they're going to stay up. And to do that, you have different types of quorums that you can set up. You have nodes, and each node gets one vote. Then you also have a witness, and that witness could either be a disk or a file share. And when we talk about it, we'll tell you which ones that we recommend. But for Hyper-V environments, you can look at them. So first of all, in this environment, I have a 4-node cluster with a disk. That's one way of doing it. That's a quorum type where it's disk only. And we don't recommend just using disk only as your quorum type because it doesn't give you enough flexibility if things go down because they both may be able to see the disk or something like that. The next one is node and disk majority. In other words, I have 4 nodes and the disk, and every one of them has a vote. So now if it's split brain, and this server goes, it gets split right here, and these two can see the disk, but these two can't, then this is going to have the majority. The two disks the two servers in the disk is over 2. So it has the majority. These two are going to say, hey, we're not the majority, and they're going to shut down, drop out of the cluster. Those 3 are going to take over the clustered environment. The other one is just node majority. If I have an even number of nodes, an odd number of nodes, I would set up a node majority. And then, again, if I lose it right here and these 2 can't talk to these 3, these 2 are going to drop out, those 3 are going to take over, and they'll have the majority. Then the last one is node and file share majority. So if I have an even number of nodes, what I can do is have a file share as being that third part, that extra piece of the quorum. And what the file share allows me to do is that allows me to put it at any location. So if I'm doing, say, a multi-site cluster where I have 5 nodes at my production site and I have 2 nodes at my failover site, and I set up a file share, I can put that file share at a third site. Both of those things can try and access that file share. Now, if I lose connection between the 2 nodes, I'll know who has access to things like the file share. And by having the file share at a third site, then it means that I'm not losing just inter-network communication. So if I lost all network communication to this system, then I would lose the file share as well. But if the file share is outside of my 2 sites, it makes it a little more resilient for a larger environment. Now, if I don't have multiple sites, then obviously I can't put this on a third site. But this is just another option, especially if you're doing things like multi-site cluster, to avoid this split brain phenomena. All right, so multi-site clusters for disaster recovery. Who here has used multi-site clusters or stretch clusters? Anybody? So multi-site clusters are nice because they give me some availability and quick recovery from a data center outage. So if I have 2 data centers, I can put clusters, a clustered environment where some of the nodes are in the primary data center and some are in the failover data center. And if I lose the primary data center, the VMs or whatever the application is can be restarted at the failover data center. A lot of environments don't have multiple data centers, and if you don't have multiple data centers, that's fine. What we've seen some customers do up in the States is they work with other organizations within their area, and they buddy up, and they say, okay, we'll house some of your servers and clustering between, and you'll house some of our servers and the storage replication in between. And they can, have another customer or maybe a partner share in that DR capability. So what happens is if I lose the site, the VMs are restarted at the remote site. Now, things that I got to worry about here, and probably the biggest one, is my network considerations. If I have a primary site and the VMs have one network IP address over there, but when I move it to the secondary site, they have a different network IP, then when I bring that VM back up, I need to make sure that it has the right network environment. It needs to be reset the IP address. There are a couple ways around it, and we'll talk about those in these next things. So stretching that network. If I can, I'd like to stretch the VLAN across between both sites. That makes life the easiest. But if I do have these 2 sites, I got to make sure that the network traffic between them gets across in a rapid amount enough time so that I don't miss any of the heartbeats or those types of things. And that's where things like the same subnet delay and the cross subnet delay become important. So if I've stretched my VLAN across between the 2 sites, so it's 10 dot over here and it's 10 dot over there, then I need to bump up that same subnet delay maybe to 1500 or 2000 so that it handles the longer latency where it may take to get a heartbeat back from the other nodes within the cluster. Or I can bump up the number of heartbeats missed. I can bump up that threshold to be something that allows me to handle a larger, more latent network. If I have different subnets at both sites, then I would use the cross subnet delay and the cross subnet threshold. So the cross means I'm going from one subnet to a different subnet, and the same subnet means I'm staying within that same subnet. And I can do these through the PowerShell command, just like I showed you. So security over the LAN. You can also set the security of the intranode communication within a cluster by setting these values within the cluster environment. So you can set the security level property to a value of either 0, 1, or 2. By default, it's 1, meaning it's signed between the two. But if I wanted it encrypted, I could set it to 2. And I can do that the same way. They're doing it with their command is a little different than what I use, but I could do the get cluster.security level equals 2. And that would give me the same, be able to set the same value. So when I do set up this cross-site cluster, I need to watch out for the IPs like we talked about. So I'm either going to set, one way to do it is to set DHCP in that VM. When it comes up over here, it's on the 10.network. When it comes up over here, it automatically gets a 20 or whatever on that network. Or I can set a static IP address, and I just have to know that on the other side, if it's a different subnet, I have to have it reset the IP address when it comes up. So if you're doing cross-subnet failover, probably easiest to do DHCP. I know some people don't like to use DHCP, especially for server environments, but you can set the DHCP address and then just assign it statically to that machine if you want. So client reconnect considerations. If I was a guest and I was a user that was accessing this VM, and the VM had an IP address, it's going to create a record inside the DNS. DNS can be replicated out to wherever the user who's accessing that VM, and that VM is going to get that IP address. Now, when I fail over to a different data center, if that data center has a different IP address, then I have to update the record. So when it restarts at that new data center, it has to update the record, and that has to get updated down to the user, and the user would then see, oh yeah, it's a 20 dot address. So that's the only thing when you're doing cross-site if I have different subnets at both sites. So to get around it, what you can do is you can set it up so that, and we set up the cluster so that we prefer to fail over locally. If this system went down, it would try and start on this system before it failed over to the remote site. So it fails over to the local site, still maintains the same IP address. Or if I can stretch the IP across the two domains, the two data centers, then it doesn't matter if I fail locally or remote. It's going to have the same IP address. And this actually is what you would use if you wanted to enable long-distance live migration. If I wanted to, instead of just having the machine go down here and bring it up over here, if I wanted to migrate it across while it was live, then I can do that, but I need to make sure that I stretch the VLANs across, because if I move something around to a different subnet, then it doesn't matter. I wouldn't be able to get out there anyways until I rejiggled the IP address. Was there a question? The question is, how do these clusters manage storage replication? I'm going to get to that in like 3 slides, so I'll talk about it in there. All right, so one other way of getting around this is to use something like a load balancer, where I can abstract the network from the different sites. So everything feeds into the network load balancer. When the machine fails over, the guest or whoever, the client, is always accessing the same IP address. It's just the VM's IP address may change or not as I go between sites. Again, this wouldn't work for long-distance live migration, but would definitely work for moving the machine around without having to worry about updating DNSs or anything like that. All right, so live migration across sites. This is something that we showed off. We showed off at MMS this year. It is something that we've worked with a few of our storage vendors to prove out. But it allows me to take a virtual machine that's running at one site, instead of just live migrating it to another host within the cluster on the same site, actually live migrate it to the other site that's on this setup in this multi-site cluster. Why would I want to do that? Well, now instead of rebalancing across machines in the same data center, I can rebalance my workload across entire data centers. Gives me a little advantage there. Another example is I have a customer that had an expensive data center in the downtown of the city that they were in, downtown Chicago, and they purchased a brand new data center just outside of Chicago in a much lower expensive environment where they could have a much larger data center so they could grow their environment. But they had to move these applications, and these applications couldn't go down. So by setting up a multi-site cluster between these two sites, they can live migrate to the other site and move their applications over there, and then build out their cluster at that side, keeping their now original data center as their DR site. So if I'm doing live migration across sites and I want it seamless to my customers, then I need to make sure that the VLAN is stretched across the two sites. Besides that, the easiest way to do a lot of this multi-site clustering is to stretch your VLANs. If you can't do that, though, you can get around a lot of these things by manually resetting things or using things like DHCP. All right, so storage in multi-site clusters. I've set up this multi-site clustered environment, and that's great for the network. I've set that across between the two sites, but I want to set up also the storage because I have to have storage replication between the two sites. And that's where our work with our partners comes into play. But I have two options for replication. I can set up either synchronous or asynchronous replication, and depending on that will depend on if I can do things like long-distance live migration or not. So I have to replicate the data, and we've worked with our partners, the main storage vendors, to support this. So companies like EMC, NetApp, HP, IBM. They've all designed their clustered. They've all worked with us so that their storage environment works on multi-site clusters by doing things like in NetApp Metro Cluster and HP using their CLX technology to extend that cluster across. And I'll show you that in a little bit. But there's other ways of doing replication across sites, and you could use software replication where the VM is running an application like DoubleTake, and it's replicating to another VM that's running the DoubleTake software, and it will replicate all the data across over the network between the two sites. So it's a little different. It's not using the storage vendor to replicate the data, but instead is using application inside the VM to replicate that data. Or you can use things like storage appliances where all the Hyper-V servers hit the storage appliance, and the storage appliance determines where those virtual machines are stored, the lens they're on, and it handles things like replication and moving things around. So there are other ways of doing it that way. But how it works is this. You can either use synchronous replication or asynchronous replication. And the biggest difference here is how far apart these things are and how big your pipe is and how much data is changing. But the issue here is that on synchronous replication, I don't get a write back from a write request. So the VM makes a write request. Well, the VM makes a write request. The Hyper-V host then makes a write request to the storage. Now, in synchronous replication, the storage replicates it over to the secondary storage, gets an acknowledgement back that, hey, the write worked. Then it acknowledges that the write's complete back to the Hyper-V host, which then passes that up to the guest. So I have to wait till it makes that whole round trip, and that's why there's distance limitations for things like synchronous replication. With asynchronous replication, the VM is told immediately, once it makes the write request, once it's written locally, it's passed back to the guest. So the Hyper-V host makes the write request then is acknowledged, and the guest continues on its way, and then sometime in the back end, as close to real time as possible, it copies the data back over to the remote site. So here you may have some discrepancy as far as how much time it takes between when the data was written and acknowledged at the primary site and when it was actually physically updated at the remote site. That's why you can't use live migration for asynchronous replication, because we can't guarantee that the two disks are in sync. So when you're doing multi-site clustering environments, you don't have to pass the cluster validation steps on the storage parts for multi-site clustering. And we have a guide as to what's there. I mean, you got to make sure in the back end you've tested it, you know that it works. But because of the fact that you're doing things like this cross-site cluster and this replication stuff, you don't have to pass the storage test to still be supported, as long as you follow the stuff within the guide and the policy that's posted up there. The next thing is, if I want to do multi-site clustering and I also want to do CSVs, can I do that? And the answer is yes and no. Some of the storage vendors, when they do a CSV or when they do replication, it's a read on one side and read only on one side and rewrite on the other. And if I had servers on both sites trying to write to different VMs within their site, then it wouldn't work. Other vendors where it's read-write on both sides and it handles the writing between the two systems, those would work. And so you have to talk to your storage vendor to find out if they support CSV environments for Hyper-V and multi-site clusters. If you are doing that, if they support it, then you could probably do things like live migration. Shouldn't be a problem. But if they don't support it because one's read-only and the other's read-write, then you're not going to be able to do live migration with CSVs. And that's the example I'm going to show you in a little bit. So when you do storage virtualization abstraction, the same thing. They handle the replication and everything, access to the LUNs in the back end. You just access the same LUN within there. And so it does work with CSVs, provided the storage vendor has tested it out and certifies it. So if we're looking at CSVs, basically, like it says over here on the right, you want to consult your vendor. And things like live migration will work, hardware replication, software, and appliance. Some of those things are going to work for you. Software replications, not. But besides that, they will work provided the vendor supports that environment. We look at time-wise, we're almost done. So let's go quickly through the quorum. Then I want to show you a quick demo of this. So when you're doing multi-site cluster, of the two that we talked about earlier, if I'm using an even number of nodes, the best thing to use is the node and file share majority method for multi-site clusters, and try and put that file share for the cluster at a third site if possible. If I have an odd number of nodes, then just node majority is the best technique to use for multi-site clusters. All right, so we talked a little bit about one of the environments to demo. And what I want to do is I want to show you what it looks like in the back end for HP's CLX technology. All right, so here we go. I'll flip it over in a sec. All right, so what we're showing here is HP's CLX technology. It's a video I recorded because I didn't have the ability to transport two HP EVAs down here for showing you this. But what's happened is that we have two LUNs in this environment, and two EVAs, an EVA at one side and an EVA at a remote site. And those EVAs have a couple of LUNs on them. And the LUN that we're going to be talking mostly about is this ConApp 01. And this LUN has the bottom EVA is the actual source of this, and it's set up in a read-only mode. And it's presented to one of my blades in my environment. So I have a blade environment, and I'm replicating with the other EVA. This blade is connected to the one EVA. The other blade is connected to the other EVA. The other two blades are connected to the other EVA. So in the top EVA, I have that same disk, ConApp 01, and it is being the destination, and it's set up in read-only. So EVA's technology for replication is read-write on the primary side, source side, read-only on the destination. And in this one, the two blades at my remote site are the destination, and I've set it up destination, synchronous replication between them. And if we look at what a data replication means, the DR group is set up for this LUN, says that we're read-only on the one site, we're read-only on the destination site, and we're read-write on the primary site. So this will get through this pretty quickly here. Once it connects over, this DR group says that LUN is the one we're talking about. The destination's read-only, like I said, and the primary site's read-write. So now if we go to Failover Cluster Manager and we look at one of the LUNs, or one of the VMs, and I'm going to look at this ConSQL VM, that VM has these things called this EVA resource. So what our storage vendors have done is for every cluster disk resource that I want to make sure is supported in this multi-site cluster, I create this CLX resource, this cluster extension from HP, that the disk resource relies on. So that disk can't start until that CLX resource starts. And the CLX resource is the properties of it say that it's using the DR groups that we had before, and it's using the HVEVA top and bottom, and that you specify which data centers they are. So it's a 2 data center environment. DCA has the 2 nodes in Chicago. DCB has the 1 node in the suburb of Chicago, Joliet. And at this point, I've just set up the environment so that the resource knows which VMs, which hosts are accessing which LUNs from which site. Once that's all set up, I can now do things like initiate long-distance live migration. So the first thing I'm going to do is I'm going to start the virtual machine up. And when I start the virtual machine up, it's going to first bring up the CLX resource. And then after the CLX resource comes up, it can now bring up the disk resource. And then once the disk resource is up, it can bring up the virtual machine itself. I'm doing this in Cluster Manager. I actually have done this in VMM as well, but I wanted to show you everything in Cluster Manager, and then if I think we're out of time, so we won't be able to show you the other stuff as well. But when I live migrate the virtual machine from one site to another, it'll start kicking off the live migration process. The VM will be running at site A, and it'll be transferring all the memory and contents of memory across to the other site. Now, while it's transferring that memory across, the VM's still running at site A. The site A is read-only, the read-write disk. The other site is still read-only. When this gets to 98% or whatever the value is, when it flips the switch and it pauses the VM, moves it around, and starts the VM over here, at that point, what will happen is the VM will go down, this VM will go from online to offline, the disk will go online to offline, the HPCLX will go offline. It'll flip in the back end the read-only, read-write from site A to site B, so it'll flip them, so that this site now becomes read-write and this site's read-only. And then it'll bring it back up, bring the disk back up, and bring the VM back up. So it handles the read-only, read-write access capabilities. By having both of those systems as read-only, both of the LUNs have read capabilities. That means that all the hosts can see that LUN, so they all think they're talking to the same LUN. But the HP technology handles who has physical access to write data to that LUN. So I can do the same thing here. I can take a VM and I can right-click and say, hey, go to the other database. And then within VMM, it just kicks off the VMM stuff. And you don't really notice that it's going to a different server and a different data center. It's just transferring the data across and thinking that it's all local. And that's one thing to remember is that in VMM doesn't make a distinction in a multi-site cluster and know that these sites are in one cluster and these nodes are in one site and these nodes are in another site. So things like intelligent placement, it's just going to pick whichever physical Hyper-V host it thinks is the best one to use. That's something I've actually talked to the VMM team saying, hey, if customers are going to start doing this, we need to kind of set priorities so that the VM will try and move just within its site before it tries to move to another site type of thing. But at this point, it's now taking the LUN off and bringing it back up. And so as you can see, it just runs, the live migration works just fine, even if I'm moving from SAN to SAN. So I'm not going to go through and show you, that it works, live migration. You've already seen live migration before. So what we'll do is the last couple of slides. Now in this deck, I have a bunch of appendix slides that kind of go a little more deeply into things like the quorum disks and into some of the other things in multi-site clustering. So if you have questions, go look at that information as well. We also have some data center for disaster recovery partners. One of them is Citrix, and I think Citrix is going to be on right after this. So if you have questions about their Citrix Essentials for Hyper-V and how it does site recovery, they're going to be able to talk about that for you. And then lastly, for configuring VMs for high availability, it's the norm now. A lot of people are doing it. Most people raise their hand as far as availability. Each model has its advantages, whether you're doing local or you're doing cross-site, whatever kind of storage you're using, and then choose what's right for you. So if we look, those top 17 different things, spindles, no shared storage, cluster your hosts, cluster your apps, it's all fine. And then lastly, the ones that I think are probably the most important here are, handle your network slowness with that same subnet delay settings, using CSVs. You leverage them as much as possible. It gives you a lot of advantage as far as SAN management within clustering. And then make your VMM highly available by putting it on some type of highly available system. And then lastly, probably the most important is the spindles one. So with that, I really appreciate your time today. I have a bunch of posters up here as well as these little Hyper-V teddy bears. So anybody who wants any of those, please come on up and we'll get them for you. Appreciate it.